Good morning, everyone. It's Thursday, April 12th. It's about 8:30 in the morning. This is Inta Mitterbach in Lakewood, Ohio. This is my mini broadcast, of which this is mini broadcast number 3, Northern Border Broadcast Productions. And Lakewood, Ohio is a suburb of Cleveland, and I'm in the United States. I went out this morning and noticed that the moon was above the, it's out there to the, from here, it's out there to the south, maybe a little west, a little while ago when I was out there looking at the sky. And I've got a picture here I'm showing you of the moon. And it's funny, I thought about NASA my whole life and astronauts and some of the television shows that we're on and watching the space program, and it never occurred to me. I looked up at the moon, and I drive to work. I'm heading east in the morning into the sun, blinded by the light. And there's the moon occasionally. And one day I woke up 32 years later and realized, why is the moon there, and how did it get there? It just, what were all those children's songs that we sang about? You see pictures of the moon in children's books, and the moon is always out there in the sky at night. And, I drove around seeing the moon during the day, but it just really never occurred to me. And I started thinking about the lunar orbits and all of that. I've taken an astronomy class now, but I'm still trying to figure out where the moon is and how it got there, and kind of a Galileo thing maybe, or whomever. Copernicus, was it Copernicus? Trying to figure out if I could, without looking at a book, and I have looked at some of the books, but I'm still trying to figure out if I could map the orbits of the moon according to observation, of which, that's what the scientists did a million years ago. So I was trying to figure that out, and of course, you've got the, what is it? Sometimes you see a half moon, a quarter moon, and so you've got the lunar cycle and things like that. But I was so anyway, it's full broad daylight. It's a beautiful day. It's sunny. I have no idea what the temperature is, but it's a little bit warmer today. It doesn't look like it's going to snow. It looks like a beautiful spring day, and the sky is, I think it's completely clear. There's not a cloud in the sky that I recall. I took some pictures. I go out every morning, not every morning. Sometimes I go out, take some pictures of the sky, and I take pictures in all 4 directions. And try to take some sky shots. If I see some interesting cloud formations, I take pictures of those. And so I took some pictures of the sky this morning, and it's just kind of funny. I just woke up, and I did wind up getting to work at NASA, and I learned some interesting things. And I've thought about, what it takes to get how did they get to the moon, and what did it take? And you start thinking about the weather conditions and where was the moon, and maybe there's a what's it called? A pattern. Here's my cryptic little mind working. Maybe there's a pattern to the launches, the shuttle launches, in terms of the placement of the stars and the sun and the moon and everything. Maybe there's a pattern to the launches. If you think, and this just occurred to me, where was the moon in terms of placement when the rockets were launched for the space program, the missions to the moon? And so anyway, there's another thought that just flew into my brain. One of the things that was kind of funny, and I'm going to try to wrap this up real quick, but one of my little wake up and realize what you missed because you didn't pay attention in school and you were distracted and you didn't start thinking about anything until you were in your 30s. And I guess it took a near-death experience for me to wake up, and I've been thinking a lot for the past 16 years, I guess, since, and it's been difficult losing things. But let me get back to this. As far, what was I going to say now? I was talking, okay, here it is. I was talking about, is that eagle, the eagle that landed on the moon, how aerodynamic is that, and can it relaunch to the capsule and jettison back to the Earth? And, one of the things is that capsule going to get thrown out of orbit, lunar orbit, when the eagle tries to engage with it, and how real is that? What's the accuracy that would be needed to get that eagle off the surface of the moon to engage? Then the astronauts have to transfer from the eagle to the capsule. I mean, is this a joke? How did the astronauts transfer from the eagle to the capsule, and then that jettisons back? This is really scary, because I'm like, did they really ever come back from the moon? Did they ever really make it to the moon? And so here's the thing. The capsule, let's assume that's all correct. Then the capsule jettisons back to the Earth, crashes through the atmosphere, and exactly how high is the atmosphere and how thick and stuff? What area of the atmosphere does the capsule actually have to crash and burn through? What's the density of the atmosphere as it rises, and does it get thicker as it goes out there? At what point does it get, is it thicker, but then it's not as thick, or when it comes closer, because there's that friction and burning thing going on, and they had to make sure that the materials, in terms of re-entry and the burn and everything. So there's that. But anyway, so I'm trying to figure out, okay, these poor little astronauts, they're in this capsule, it's falling to the Earth, and it crashes down in the ocean. So, okay, here it is. It's crashed down into the ocean. It hits the water. I have been in car accidents, and I had fully padded vehicles and a seat belt. And when I got hit, it hurt. So these guys are crashing down in this lunar capsule. Are you crazy? Look at the materials of those seats inside the capsule. It's hard as a rock. Is it metal, plastic? No cushioning whatsoever. And then they've got their little space suits. What's the material of that? There's no cushioning, no padding, and they're crashing. So anyway, then I went off with how fast are you going when you're crashing? And then I had forgotten about the parachute. So you have to calculate the deflection. Is it deflection or resistance of the air resistance using the parachute of the capsule crashing down to the Earth? So I went off on a tangent and tried to figure out what's it going to take to calculate that. And then you've got the size of the parachute, the materials of the parachute, then you've got the ropes, you got the whole works. That in itself is a calculation problem. That's going to take a lifetime for me. And then I'm thinking, I think someone said the capsule came down. I called the Science Center, and they said, some kid who's an expert said, the Great Lakes Science Center, he said it comes down at 20 miles per hour. So I'm driving through the school zone in front of the school. The school is 20 miles per hour. So the next time you drive through the school zone going 20 miles per hour, crashing, I'm approaching the Atlantic Ocean. I'm crashing. I'm landing. Here I come, landing into the ocean. I'm speeding down from the surface of the moon through the atmosphere, through the Earth, and maybe try to think about, a 20-mile-an-hour crash and how, what that feels like. But I'm not. I really think they were going a little bit faster than that, and it's a real puzzlement to me, and that's Dad's word, a puzzlement. So anyway, good morning to everyone. Have a great day. Think about it, and like I said, I like doing these. Maybe I'll just keep posting my brain onto the internet, and if you like listening to these. And I'm sorry, this is now over 9 minutes long. Have a great day. Bye.